Kane Ace MX Performance Solutions. Core shell rubber particles have been used to toughen various polymeric systems since the early 1960s. As the name core shell rubber implies, a CSR particle begins with a spherical core. This core is typically comprised of a butadiene styrene copolymer, which is essentially a rubber compound. The chemistry of the core provides the impact modification performance and toughening desired for the polymer matrix. The shell is then chemically attached to the core, with the dual purpose of both isolating the core from the resin system and providing chemical compatibility with the polymeric matrix. The shell chemistry normally exhibits an acrylate chemical character. Over the last 40 years, hundreds of CSR products have been synthesized. They are differentiated by core composition, shell chemistry, particle size, and core-to-shell ratios. CSR products historically have been furnished as a solid dry powder, comprised of grains containing hundreds or thousands of agglomerated primary particles. Powder CSR particles have been successfully used in thermoplastic systems such as PVC for more than 4 decades. Global consumption of powder CSR particles is estimated to be well in excess of 200,000 metric tons annually. CSR particles toughen a polymeric matrix in multiple ways. The core acts to dissipate the energy of an impact. This cavitation theory of impact modification describes the CSR core deforming, effectively mitigating the energy of the blow. CSR particles themselves also act as crack terminators. Cracks or fissures that start by any mechanism are stopped when they encounter a CSR particle. Optimizing the size and dispersion of CSR particles in a polymeric matrix increases the probability of the crack meeting a terminator. Historically, attempts to mix CSR powder with epoxy and other thermosetting resins have typically resulted in very poor dispersions, characterized by settling or phase separation and inherently non-homogeneous levels of toughness. Kaneka, Texas Corporation has developed a process wherein the individual 0.1 micron CSR particles are dispersed and maintained in the matrix independently. The Kane Ace MX product line allows epoxy processors for the first time to easily and cleanly employ core shell rubber in a multitude of applications. Kane Ace MX products are extremely stable and can be stored for years without agglomeration. Formulating is easy. Kane Ace MX can be mixed into a system in just minutes with normal stirring. This image shows cured composite that has been cross-sectioned and stained to highlight the CSR particles within the matrix. Notice the shell stains darker than the core or the surrounding polymer. The 100 nanometer particles are evenly dispersed, providing numerous sites for cavitation and crack termination. Kane Ace MX products improve the overall toughness of polymer. They increase performance properties such as T-peel strength, lap shear strength, and fracture toughness without depressing the glass transition temperature, which is a common flaw of other impact modifiers. Applications for Kane Ace MX include composites, adhesives, encapsulants and potting compounds, coatings and copper-clad laminates, Kaneka Corporation. Modifying your world.